Order of operations, evaluating numerical expressions. That's what we're going to do today. Order of operations. You might have heard of the mnemonic, please excuse my dear Aunt Sally, or PIMDAS. I've got it written up here. So here's the order of operations. We can't just do whatever we want. There's actual rules that we have to follow, mathematical rules, and they're this. When we have an expression, and an expression does not have an equal sign, an equation does have an equal sign, but when we have to simplify expressions, we first start off with the parentheses or brackets. Parentheses first, then we solve the exponents, E for exponents. Then we multiply and divide from left to right, whichever one comes first. First come, first serve. So it could really be DM if division came first. And then add and subtract from left to right. So parentheses and parentheses, exponents, then multiply and divide from left to right, then add and subtract from left to right. And I've got an example where we might have to subtract before we add. So let's try this one. You can pause the video if you want and give it a try, and let's go over it. So I like to make sure it follows the tornado, and you want to show each and every step. So first is parentheses, okay? There they are right here. Now within the parentheses, what do we do? Do we do 2 plus 3 first, or 3 squared first? Well, once we go in the parentheses, we start back over. So the exponents. So 3 squared is 9. So we have 9 plus 2, still in parentheses, and then I rewrite this. And now we finish off these parentheses. 2 plus 9 is 11. And we rewrite out our expression. These expressions are all equal here. And now the exponents. So 5 squared is 5 times 5, that's 25, minus 11. Now what's 25 minus 11? That's right, 14. And then 14 is your simplified answer. And notice how we have like the tornado right there. All right guys, I changed this one up a little bit from the start. So let's see. We're gonna simplify 2 to the third power minus 3 times 2 plus 5. Well, first, parentheses, no parentheses. Exponents, yeah, we have exponents right here. So 2 to the third power is 2 times 2 times 2. That's 8. I can then do the 3 times 2 with the multiplication. So when you get a little bit better at this, you can go ahead and just go right to this point because terms are separated by either subtraction or addition. So now, this is a special case. We have subtraction and addition. Well, here it looks like addition comes first, right guys? However, that little arrow underneath that I added means first come, first serve. In this case, subtraction comes first. So we're gonna do the subtraction. 8 minus 6 is 2 plus 5. And then this simplifies to 7. And we have our order of operations here. Evaluating numerical expressions. Evaluating algebraic expressions. Let's get started, guys. My name is Jason Jacobs, and we're gonna learn how to evaluate algebraic expressions now. We're gonna evaluate these 4 algebraic expressions when t equals 8, w equals 1/2, and x equals 3. Here we go, guys. The first step. An algebraic expression will have variables in it. Variables represent a unknown number, but here we know what the number is. So the first thing we want to do is substitute the value of these variables in the algebraic expression. We're not going to try to solve it right away. We're just going to substitute that number in and rewrite them numerically. So in essence, we're going to take an algebraic expression, replace the numbers, substitute the numbers in, and make it a numerical expression. Let's do that now. So t equals 8. I'm not going to try to do, this means 3 times t. I'm not going to do 3 times 8 right away. I'm just going to keep it simple and just rewrite it algebraically, or numerically. 3 times 8 minus 8. So the first step, I wrote the algebraic expression numerically. The next step is to follow the order of operations, which is parentheses first, then exponents, then multiplication and division from left to right, whichever one comes first, then addition and subtraction from left to right, whichever one comes first. Here we go. Multiplication first, so we have 24 minus 8. 24 minus 8, That is 16. So we evaluated the first algebraic expression. Let's go on to the next one. First step is substitute the values in. Why don't you pause the video and give this one a try? So we're going to substitute these values in for w and x. So 6 times, when the coefficient is next to the variable, that means you multiply. 6 times, what is w? A half. So 6 times a half. Divided by x. X is 3 plus 9. All right, what comes first? Multiplication or division? Well, multiplication or division, first come, first serve. So in this case, multiplication. Now 6 times a half, that's 3. Half of 6 is 3. So we have 3 divided by 3 plus 9. Well, division comes before addition, so 3 divided by 3 is 1 plus 9, and that equals 10. Let's go on to this one. First step, write this out numerically. Substitute these values in. So we go 8 squared minus 12 times w, w is 1/2, divided by 3. All right, first parentheses, nope. How about exponents? Yeah, we have some exponents. 8 squared means 8 times 8. 8 multiplied by 8, that's 64, minus 12 times 1/2, divided by 3. And now we do the multiplication here. 6 times a half, that's 6. So 64 minus 6 divided by 3. And now 6 divided by 3 is next. So we have 64 minus 2. Hope you can see that. And 64 minus 2 is 62. Pause the video, give this one a try. All right, first things first, I'm gonna substitute these values in. I'm saying the word substitute these values in. Substitute, because that's what we do. You'll see that a lot. So 5 times 3, x is 3, minus 2 times 1/2, plus t is 8. All right, let's give this a try. So first is parentheses, nope. Exponents, nope. Multiplication, yeah. So we have 15 minus, and I'm going to do this term now too. 2 times a half is 1, plus 8. Here's a really great example, guys, because what comes first, subtraction or addition? Well, up here, if you look up a PEMDAS, it looks like addition comes first, but it's first come, first serve. That's why the arrow's there. So it really could say SA instead of AS. So subtraction come first come, first serve. And 15 minus 1 is 14 plus 8. And 14 plus 8 is 22. And we have evaluated algebraic expressions by first turning them and by substituting the values in and turning them into numerical expressions and following the order of operations. Combining like terms. That's what we're going to learn today. How to combine like terms. Hey, I made a little model. These squares represent x, and these circles represent integers, like numbers, whole numbers. So let's see, how many squares do I have? Well, 4 of them. So that represents 4x plus 3 plus 2x plus 1. So now we have to, it'll say on your worksheets or whatever you're doing, combine like terms or simplify each algebraic expression. So in order to do that, you have to know, okay, well, how do I simplify that? What do I do? Well, what I like to do is like model it with these pictures. So there are 4 x's and 2 x's. Put those together and you get what? So 4 x's and 2 x's equals, that's right, 6x. So 6x plus, and now you have 3 circles and 1 circle. 3 plus 1 is, that's right, 4. So this simplifies 4x plus 3 plus 2x plus 1 simplifies to 6x plus 4. Now what a lot of students do, guys, is they'll say 6x plus 4 equals 10x. Well, that's not true because we're combining like terms. The squares are not like the circles, okay? Think of it like that. So 6x plus 4 is the end. You cannot combine. These are unlike terms and you can't combine them any further. Just like if I were to say, you can't put the circles with the squares. So I hope this model helps you with that. So 4x plus 3 plus 2x plus 1 simplifies to 6x plus 4. Now let's look here. X plus x plus x plus x. Well, that's 4 x's. There's an assumed 1 here. So 4 x's equals 4x. Now you have 4y and you take 1 away. So pretend I have 4 squares in my hand. You take 1 away. How many do you have left? 3y. So this one simplifies to 3y. Now for this, you might have noticed up here, I put underneath a coefficient and a variable, I put 2 lines, and underneath just the integers, just the positive or negative whole numbers, I put 1 line. So I'm gonna match those up at the end. So we have 2x, that's a like term with x. You take the sign in front. The sign in front goes with it. And then 3 and 2 go together. So 2x plus x equals 3x. Plus 3 plus 2 is 5. So this one simplifies to 3x plus 5. You can't go any more because these are squares and those are circles and they're apples and oranges. They don't go together. All right, so 3x plus 5. Although apples and oranges, they sound pretty good right now. Let's look at this one. I put a negative integer here, and think of these signs as this one goes with this one. The plus sign goes with the 2x. The minus sign here, think of that as like negative 5, and then positive 6x, and then positive 7. There's an assumed positive sign there. So 2x and 6x equals 8x. Plus, now this is like 7 minus 5. Okay, so 7 minus 5 is 2, positive 2, which is why I have that. So 8x plus 2 simplifies that. Hey, that was combining like terms. I hope this helped you. My name is Jason Jacobs. I'll see you next time. Bye. Combine like terms. I went a little more advanced with this combining like terms. Let's get started. My name is Jason Jacobs, and we're gonna learn how to combine like terms. Let's do it. X plus x plus x. How many x's do you see? That's right, 3 x's. So that equals 3x. A little vocabulary to increase your math literacy. The 3 is the coefficient and the x is the variable. And there's 3 of them. Let's look at this one. 3x plus 4 plus x plus 7. Combine like terms. But what I like to do, underneath the coefficient and variable, I put 2 lines. I'm gonna put those together. We take the sign in front. Underneath just the numbers, the integers, I'm gonna put 1 line. Now I'm gonna combine them together. The positive 3x goes with positive x. That equals 4x, guys. 4x. Now, the 4 goes with the 7. Positive 4, positive 7, that's 11. So 4x plus 11. Now I can't combine it any further. 4x plus 11 is all it goes, guys. Think of this as 4 squares and 11 circles, like we did in the last video. I can't put the circles with the squares. I can't put the squares with the circles. All right, now I put negative integers in here, which hopefully won't mess you up, because watch. Positive x, positive 6x, and a negative 2. So we have x plus 6x, now that's 7x. Now, 7x minus 2x is 5x. So we have 5x here. And now, a negative 5 and a positive 7. Negative 5, so you lost $5. You gained $7 back. What's your net? What do you have now? What's your net worth now? Positive 2. So it's 5x plus 2 is how this simplifies. You can't go any further. Think of the 5x as 5 squares, and the 2 is 2 circles. You can't put the squares with the circles, okay? It's like apples and oranges. They don't mix. So you have 5x plus 2. Let's go on to this one now. Now, in this one, I added some exponents. So I'm gonna put 3 lines underneath the exponent one. X squared, positive x squared, and positive 2x squared. Those go together. So all the x squares go together, and you have 3x squared. 3x squared. Now, I'm gonna put the 3x and 2x. Those go together. Positive 3x, positive 2x, that equals 5x. So 3x squared plus 5x. And now just the integer plus 5. So this one simplifies when you combine like terms to 3x squared plus 5x plus 5. Hey, this one here, listen guys, this one here, a lot of students have a common mistake. They love putting these on tests. And they're like almost every problem in our book will have something like this because a lot of students mess it up. A lot of students think that you go 6 plus 3 first in this case, but no, look, when you see parentheses next to it, you got to do the multiplication here. First, so we got to simplify it all down. Notice all these are separated by terms. Terms are separated by either addition or subtraction. But here, it's not fully simplified yet. So you got to simplify that algebraic expression all the way down to terms and then combine those like terms. So we're going to do the distributive property here. The 3 distributes to the 2x and the 4. And I'm going to rewrite this here as 6 plus 6x, 3 times 2x is how I got that, plus 3 times 4 is 12, minus 2 plus x. So that simplifies there. Now we have terms that I can work with to combine like terms. Okay, again, the common mistake a lot of students do, well, they'll do 6 plus 3 and get 9. Wrong, don't do that. Okay, now, the 6x goes with the x, and that equals 7x. So we have 7x, and now this 6 goes with the 12, positive 12, that's 18, and then minus 2, that's 16. So 7x minus 16. 7x minus 16. Algebra models, look at these guys, algebra models. We're gonna learn all about algebra models right now. So in algebra models, we're gonna have a square represent x, and we're gonna have a circle represent an integer, like positive 1, for example. So this is saying 3 squares plus 4 circles equals 10 circles. So 1 square equals how many circles? Well, I want you to think of this like a balance scale, okay guys? A balance scale. And our goal is to get one of these x's by itself, okay? In order to do that, we're gonna be like a balance scale. I'm gonna take 4 of these away. So if I take 4 away on the left side of the equation, I have to take 4 away on the right side of the equation. All right, now we have 3 squares equals 6 circles. So if I just do 6 divided by the 3, I can see 1 square. Each square represents 2 circles. So 1 square equals 2 circles. Now this is the visual way to understand algebra. I really started to understand algebra when I would do this visual method. But I'm going to now show you the abstract method. So what this is 3x. 3x plus 4 equals 10. So when we see this, we're like, okay, but maybe this model helps you. It's my hope it does. So the inverse of adding 4 is subtracting 4. So remember when I took away 4 on each side, guys? That's what I'm doing here. So now I have 3x equals 6. 3x's equals 6. And now we'll divide by 3 on both sides. Divide by 3. You get 6 divided by 3, and you get 2. So x equals 2. You should always check just to make sure it's right. 3 times 2 is 6, plus 4 is 10. That checks out. Now let's look at this model, guys. You ready for this model? Here we go. Wow. 2 squares plus 3 circles plus 4 squares plus 2 circles equals 5 squares plus 7 circles. So 1 square equals how many circles? Wow. Wow, guys. Well, let me break this down for you. What this is really saying is 2x plus 3 plus 4x plus 2 equals 5x plus 7. Now, guys, if you got a problem like this, would you like go, what? I know, right? It looks so complicated. Stick with it. Don't turn off the video. Don't turn off the video. Watch this. Watch this. You can do this. I believe in you. You can do this. All right, you're with me. We're gonna put this model Up here, I'm gonna simplify it. So look, I have 1, 2, 3, 4, 5, 6 x's. So I'm gonna put 6 x's here, just like this, guys. All right, so there are my 6 x's. This is called combining like terms. Now, 1, 2, 3, 4, 5 circles. 5 circles go there. I combine those together. So notice how 2x plus 4x combines to 6x, and then 3 plus 2 combines to 5. Now it's equal to, and then this is already combined, so that's good, 5 x's plus 7. All right, so we can just write that here. Now, I want you to think of it like a balance scale. So it's like a balance scale, guys. I have to get rid of, I'm gonna get rid of these 5 x's. I chose this because there's more here, so I know I can take 5 away here. If I take 5 away on this side, I've got to take 5 away on this side of the equation. I'm left with 1, all right? So 1x equals, now there are more integers here, more 1s here, more circles. So I'm going to take them away here. I'm going to take 5 away here. If I take 5 away here, I have to take 5 away here. 1, 2, 3, 4, 5. I'm left with 2 circles. Therefore, 1x, 1 squared equals 2 circles, or 1x equals 2. Now, you saw this problem, how complicated this was. Hopefully that makes sense. So, we combine like terms, and now what I did was, remember the first thing I did was I took away 5 x's. So I'm taking away 5x there, and I'm taking away 5x there. I'm keeping it balanced. You can draw your line to keep it balanced. This cancels out. This becomes x plus 5 equals 7. X plus 5 equals 7. And then remember what we did? We took away these 5. So subtract 5. Do I still have board left? Subtract 5. And now these cancel, and you get x equals 2. Of course, it's always good to check your work. So let's do that now. X is 2. 2 times 2, I'm going to go to the one that was simplified, combined like terms. 6 times 2 is 12, plus 5 is 17. 5 times 2 is 10, plus 7 is 17. 17 equals 17. There it is. Okay, I hope these models help. I know it can be a little confusing. I'm actually going to show it where you can do hands-on. You could get like some toys, like one set of toys represents the x's and one set of toys represents the circles, kind of like this, and you could model it all out, which is what I do in the classroom. Hands-on algebra. These are algebra models that you can draw to help you as well. I'll see you later, guys. Bye. Looks like school's out. Algebra, one-step equations, here we go. When we're doing algebra, we gotta remember the inverse operations, So the inverse operation of adding is subtracting. The inverse operation of subtracting is adding. The inverse operation of multiplying is dividing, and the inverse operation of dividing is, of course, multiplying. You know that, and you can do this. Think of a scale with algebra. Algebra, whatever you do on one side, you have to do on the other. Let's get going. All right, so we have x plus 5 equals 7. So some number plus 5 equals 7. Well, the inverse of adding is subtracting. So we're going to subtract 5 here. And whatever you do on one side, you have to do on the other. So we're going to subtract 5 here. So now, positive 5 minus 5 equals 0. That's what inverse operations, you're either going to make it equal to 1 or 0. When you're multiplying and dividing, you're making it equal to 1 because 1 times anything is not anything because of the identity property of multiplication. So here, 5 minus 5 is 0. So that cancels out and we get x equals 2. Now it's always good, guys, to check to make sure that that's right. So let's plug in x equals 2. It's always good to circle your answer too. 2 plus 5 is 7. That checks out. Now sometimes, this is the way I like writing it, and then I show it canceling like that. However, in Envision, the math program we're using, it has you showing it like this. X plus 5, and instead of doing the minus 5 like that,
they do x plus 5 minus 5 equals 7 minus 5. And then you get to the x equals 2. Because 7 minus 5 is 2. So you want to get x by itself on one side, and whatever you do on one side to get x by itself, you have to do on the other side. So x minus 4 equals 8. What's the inverse operation of subtracting 4? That's right, adding 4. So we can add 4 here. That cancels. Add 4. We get x equals 12. And now we'll check to make sure that that's correct. 12 minus 4 is 8. And that works out. Now, the way they might have you show your work is this. X minus 4 plus 4 equals 8 plus 4. So that's how you can show your work if you've got to like type it in the computer or something like this. I personally really like doing it that way. That's the way I've done it my whole life, and it's served me well. Now, 3 times what equals 12? 3 times what equals 12? Well, the inverse operation of multiplying is dividing. And when you divide, I want you to think of like a fraction is dividing, okay? So I'm gonna go divide by 3 and divide by 3. Whatever you do on one side, you have to do on the other. So the inverse operation of multiplying is dividing. Now 3 divided by 3 is 1, and 1 times x is x. Now we got to divide by 3 on the other side. So now we got x by itself, which is one of our goals. 12 divided by 3 is 4. So now let's check. 3 times 4 is 12. You're getting it. A lot of these you might be able to do mental math. I get it. I can just look at them and know too. But what we're learning here, guys, really important, is the process of showing your work. You're going to hear your teachers say, show your work. You got to show each step, because soon you're going to get to two-step equations, then multi-step equations. You really got to show every single step, and this teaches you how to do that, okay? Now this is the way I do it, and this is the way our new Envision books are having us show the equations. All right, 7 times x equals 21. The inverse of multiplying is dividing. So we're going to divide by 7 on those sides. That cancels out. Well, it becomes 1, and then 1 times x equals x. So now we have x equals 21 divided by 7, which is 3. All right, so let's see. 7 times 3 is 21. That works. Now, you might have to show your work like this, so I'll just show you for completion's sake. 7x divided by 7, 7x divided by 7 equals 21 divided by 7. Does that fit on the screen? Yeah, that does. All right, so they might have you show your work like that, which is pretty much what that is. X divided by 4 equals 6. You tried this one. All right, let's see what you did. The inverse of dividing is multiplying. So that becomes 1, and 1 times x is anything. Multiply by 4 here, and you get x equals 24. And let's just check to make sure that works. 24 divided by 4 is 6. That is true. Now, this is the way they might have you show your work. I'll try to make sure the screen can see it. X divided by 4 times 4. I should probably use times multiplication symbol like a dot, equals 6 times 4. All right, so you might have to show your work like this. I prefer this way. What happens when the x is right here? I mean, usually the x is here. Well, the commutative property says we can rewrite it as x plus 6 equals 13. So you can do that if you want, but just think, right here is, it's assumed that that's positive. So you're not looking at this sign, but we're gonna take 6 away here, take 6 away here, and we have, now x is by itself, x equals 13 minus 6, and 13 minus 6 is 7. And let's just check to make sure this works. 6 plus 7 is 13. That checks out. And these are one-step equations. You might look at these problems and say, you know, I knew all of those without even having to do all that extra work, but it's the process you're learning here, guys. I'm using easy numbers so you can really understand it. So it's the process of using inverse operations. Next, we're gonna be doing two-step equations, all right? And you're gonna see that process. In fact, I'm gonna show you some two-step equations now. Oh, guys, I wasn't planning on doing this, but I'm gonna do it just for you, okay? Whatever you do on one side, you have to do on the other, and you're going to want to get x by itself. First thing, we're going to do the opposite of the order of operations. So we're going to get rid of this plus 4 at the end of adding 4. The inverse operation of adding 4 is subtracting 4. So subtract 4 here, cancels, subtract 4 here. Now, I usually like to draw a line on my equal sign to make sure I have both of them separated. Now, 2x comes down, so now you have 2x. I always leave a little space here. Is equal to 10 minus 4. 10 minus 4 is 6. I'm not going to write the 6 here and then write it again here. So 2x equals 6. Now you have, what's the inverse of multiplying by 2? That's right, dividing by 2. So I'm going to divide by 2 here. Cancels. Divide by 2. And now I have x equals 3. X equals 3. And that's checked to make sure it works. 2 times 3 is 6. Plus 4 is 10. That checks out. You want to do another one? Okay. A coefficient is next to the variable. That means you multiply. Coefficient variable. This is the constant. All right. So the inverse operation of subtracting 3 is adding 3. So I'm going to add 3 like this. These cancel. Now I have 4x equals 8. Inverse of multiplying by 4 is dividing by 4. Cancels. Now x equals 8 divided by 4, which is 2. So x equals 2. Now I'm going to check it. 4 times 2 is 8, minus 3 is 5, because 8 minus 3 is 5. That one checks out. Hey, I hope you learned a lot about the process of algebra. My name is Jason Jacobs. I hope you enjoyed this video. Please like and subscribe. See you later. Two-step equations, algebra. Let's get going. My name is Jason Jacobs. I'm going to teach you all about two-step equations. Here we go. 3x plus 5 equals 29. So in order to figure out what x is, you guys got to be like a private investigator, right? So we're going to use inverse operations. The inverse operation of addition is subtraction. The inverse operation of multiplying is dividing. So I like to put a little line right here to help me. And whatever you do on one side, you have to do on the other. I want you to think of like a balance scale, guys. Okay, here we go. The inverse of adding 5, we're going to do the reverse of the order of operations. Inverse of adding 5 is subtracting 5. So I'm going to subtract 5 here. And whatever you do on one side of the equation, you have to do on the other. So I'm going to subtract 5 right here. So now 5 minus 5, well, that's 0. And now we have an equation that's equal to this equation. 3x equals, and what's 29 minus 5? That's right, it is 24. So now 3 times what is 24? Well, the inverse operation of multiplying by 3 is dividing by 3. So we'll divide by 3 on both sides. And now I have x equals 8. Once you've figured out the answer, I want you to circle it. That's really important. Next, even more important, is check it to make sure that 8 is correct. The value of x is 8 is correct. 3 times 8 is 24. 24 plus 5 is 29. That checks out. Everything's good. Let's move on to the next two-stepper. All right, two-step equation here. 4 times something, 4 times x, minus 3 equals 17. Well, the inverse operation of subtracting 3 is adding 3. So we're going to add 3 to this side of the equation, cancels. Add 3 to this side of the equation. Whatever you do on one side, you have to do on the other. Now, we have 4x equals 17 plus 3 is 20. So 4 times what is 20? Well, the inverse of multiplying by 4 is dividing by 4. So you divide with the fraction, divide by 4 on both sides, and we get x equals 5. Remember to circle the value of x. X is 5. Now, very important, ask yourself, does this make sense? How do we decide if it makes sense? We're going to go through and check it. 4 times 5 is 20. 20 minus 3 is 17. This checks out. This is good. Hey, let's just go over a little vocabulary. Coefficient, variable, constant. Okay? On this side, it's an expression, but the whole thing is an equation. Okay? Because an equation has an equal sign. All right, now we have x divided by 7 plus 5 equals 14. Okay, I'm gonna draw a line, and I'm gonna do the opposite of the inverse operations. So I'm gonna take away this 5 first. So I'm gonna subtract 5 on both sides. Whatever you do on one side, you have to do on the other. Remember the balance scale? This cancels out, and this here becomes 9. Make sure you can see that. So now you have x divided by 7 equals 9. The inverse of dividing by 7 is multiplying by 7. So multiply by 7 here, cancels. Well, it doesn't really cancel, it becomes a 1, and then x divided by 1 is just x. So multiply by 7 here, and now x equals 63. Circle your answer. Let's check it, guys. 63 divided by 7, that's 9. And 9 plus 5 is 14. This checks out and makes sense. You try that one. Did you get it? Okay, maybe you pause the video. I don't know. We'll keep going. One thing I like about these videos is I go real quick. I'm not trying to waste your time. I want to go real quick through it and teach you the most efficient, effective way. The inverse of subtracting 5 is adding 5. So we're going to add 5 here, cancels, add 5 here. And now x divided by 8 equals 6. Inverse of dividing by 8 is multiplying by 8. Whatever you do on one side, you have to do on the other. X equals 48. Circle your answer. Now, see if it makes sense. Let's check. 48 divided by 8 is 6. And then 6 minus 5 is 1. It checks. You guys can do this, okay? I believe in you. Follow these steps, follow all the steps, as annoying it is to write it all down. It's actually, the process is actually kind of fun, I think. But you got this, guys. My name's Jason Jacobs. Let me know if I can help you with your math. I've got hundreds of videos online of how to do math. Anything you can think of. You got this. Bye.
Commutative property. We're going to learn all about the commutative property of addition and the commutative property of multiplication right here, right now. Hey, my name's Jason Jacobs, and I'm going to be your math teacher. I get right to the point, so let's get going. Let's play a little game. Add this up as quick as you can. Ready, set, go. You getting it? Right here. Add it up. Add it up. What did you get? Well, did you get 30? Because 30 would be the right answer. And here's a little trick. A lot of you probably went 6 plus 7 is 13. 13 plus 8 is, and like, that's daunting. But if you use the commutative property of addition, what you can do is rearrange those add-ins. So you rearrange those add-ins just the way you want. And you can do that in your head or right on the paper. Let me show you. So in this instance, I'm going to use 10 pairs. 10 pairs add up to 10 easily. And we learned that in like first grade or so. So 6 pairs with 4, I'm going to take the 6 and the 4, I'm going to rewrite it 6 plus 4. And this is what the commutative property is allowing us to do. Switch around the add-ins as long as it's all addition or all multiplication, but not a mixture of both, right? You can't do it that way. But here, so I use the 6 and 4, now the 7 and 3 I can use. And now the 8 and 2 go together. Now that makes it real easy because we have 6 plus 4 is 10, 7 plus 3 is 10, and 8 plus 2 is also 10. And that's how we get 30 really, really quick instead of feeling like we gotta go left to right. And that is the commutative property of addition. So the commutative property of addition states, as long as it's all addition, A plus B is the same as B plus A. So let's do some examples, guys. 3 plus 2 equals blank plus 3. Now, I used to teach 4th grade, and a lot of times in 4th grade, the kids would put 5 here. Do you see why they would put 5? But that is incorrect, because this equal sign says the same as. So 3 plus 2 is the same as what plus 3? So if this side equals 5, this side 2 must equal 5. So 5 does not go there. But the commutative property means you can like switch them, swap them. So 3 plus 2 is the same as 2 plus 3. And these are the type of problems that you'll see. So why don't you guys try this one now? You can also do it with 3 add-ins or 6 add-ins, as long as it's all addition in this case. So 5 plus 7 plus 6 is the same as blank plus 5 plus 7. Well, which one were we missing here, guys? That's right, we were missing the 6. So the 6 goes here. And you might be thinking, oh, so whatever number's here goes there. That's just a coincidence, okay? Now let's do the commutative property of multiplication. And that states A times B is the same as B times A. So as long as it's all multiplication, you can rearrange the factors so that it can be done easier. Similar to what I did with the commutative property of addition right here. So 5 times 2 is the same as 2 times 5. And the common mistake, some of you might have thought to put 10 there. That would be wrong. And that's okay to make a mistake, but now you know. 5 times 2 is the same as 2 times 5. And let's look at this one. 6 times 2 times 5 is the same as what times 5 times 6? Well, in this case, 6 times 2 is 12, and then 12 times something might be a little more difficult. So I would notice maybe perhaps this 2 times 5 is 10, and multiplying by 10 is a lot easier. So maybe you want to do, and this by the way should be multiplied, maybe you want to do 2 times 5 times 6, because 10 times 6 is 60. So notice we just changed these factors around. We just switched the factors around. As long as it's all multiplication, I actually had an addition there. But that is the commutative property of addition and the commutative property of multiplication. My name is Jason Jacobs. Please like and subscribe, and I'll see you next time. Keep doing your math. Bye, guys. Associative property, I marked on myself. We're going to learn all about the associative property today. Guys, the associative property of addition and the associative property of multiplication. Hey, my name's Jason Jacobs. I'm going to be your math tutor today. We're going to have a lot of fun learning all about the associative property. Let's get going, guys. So check it out. The associative property of addition says when you have the quantity of A plus B, quantity of means there's parentheses there, or grouping symbols as they like to say. So the quantity of A plus B plus C, as long as you keep these add-ins in the same order, as long as it's all addition, you can move the grouping symbol. So if it's all addition, you can take the grouping symbol from here to here. So the quantity A plus B plus C is the same as A plus the quantity B plus C. And that's the associative property of addition. So if we have this, you have 6 plus the quantity 4 plus 8. As long as it's all addition, which it is, 6 plus 4 plus 8. So you keep the add-ins in the exact same order, and you are allowed to move the parentheses from here to here. And you might say, well, why would I want to do that? Well, as you can see, this is a 10 pair, so 10s are a lot easier. We're dealing with easier numbers anyway, but if you were dealing with more complicated numbers and you can make it easier, that's why you would want to do it. So instead of 6 plus 12, which might be harder if there are harder numbers, you can make a 10 pair, like 6 plus 4 is 10 plus 8. At any rate, these two expressions are equal. 6 plus 12 is the same as 10 plus 8. They're both 18. Hey, now for the associative property of multiplication. The associative property of multiplication says, as long as it's all multiplication, A plus B, the quantity A plus B times C equals A times the quantity B plus C. Notice how the factors A, B, and C stay in the exact same order, and the only thing that move is the grouping symbols, okay? That's the associative property. So when you see associative property, I usually see 2 S's here, and I associate those with the grouping symbols. So 8 times 15, I can't really do that in my head, can you guys? Times 2. Well, if we move the grouping symbols here, because it's all multiplication, that might be easier. Let's take a look. So notice the 8, the 15, and the 2. They stay in the same order, and the only thing that we're moving is the grouping symbols. Hey guys, 15 times 2, that's 30. And then 30 times 8, well, 3 times 8 is 24, so 30 times 8 is 240. So that must mean this is 240 here, and this is 240 here. And that's the associative property of addition and the associative property of multiplication. My name is Jason Jacobs. Please remember to like and subscribe. See you later, guys. Bye. Identity property of addition. What is it? Well, we're going to get done with this one real quick. The identity property of addition says any number, let's say 2, plus 0 is 2. Notice when you add 0, it does not change the identity of the number. For example, x plus 0 is x. X is an unknown, it's a variable, and any number, let's say x plus 0, the identity doesn't change, it becomes x. So let's do these 3, see if you can get these. I bet you can. 5 plus 0 is 5, and that's because of the identity property of addition. 0 plus what is 3? Well, because of the identity property of addition, that is 3. 0 plus what is n? That's right, n. 0 plus n equals n. My name's Jason Jacobs, and this was the identity property of addition, 0 property of multiplication. That's what you're gonna learn today. Look at this, we have 5 times 0 equals 0. So any number, let's say n, times 0 is 0. It's just that simple. 6 times 0, well that's 0. That's the 0 property of multiplication. 0 times 7, yeah, that's 0. N times 0, well I guess we already did that, that's 0. 8 times what is 0? That's right, 0. Now don't get it mistaken with the identity property of addition. The identity property of addition says like any number, let's say 2 plus 0 equals 2. That's the identity property of addition, but this is the 0 property of multiplication. Okay, so this one's the identity property of addition, and this one's the 0 property of multiplication, and I bet you might get, some people get confused on that, but hey, not you now. And this was the 0 property of multiplication. Distributive property. We're going to learn all about the distributive property over addition and the distributive property over subtraction. My name's Jason Jacobs. It's an honor and pleasure to be here to teach you all about the distributive property. Hey, let's get going, guys. So the distributive property over addition says that if you have A, and then when it's right by the parentheses, guys, that means you multiply, okay? So A times the quantity B times C. So what I like to do is, it looks like this. A times B plus, there's the over addition part, and then you go A times C. So A times B plus A times C. So basically, the A distributes to the B, and the A distributes to the C. A times B plus A times C, just like that. Now the distributive property over subtraction will have a subtraction sign like right here. So you go A times B minus A times C. A times B minus A times C. So let's look here. This is the distributive property over addition. So we go 3 times x, well that's 3x, plus 3 times 2. 3 times 2, which is 6. So they might make you do this. 3 times x plus 3 times 2, and then go to that. All right? My 6 looks a little weird because I was writing 3 at first. So 3x plus 6. Again, the 3 distributes to the x, and the 3 distributes to the 2. All right, and remember, when it's right next to the parentheses, that means you're multiplying. They might even have a multiplication symbol here. Why do you think we don't have a multiplication symbol here? Because it kind of looks like the variable x, right? So anyway, this is distributive property over subtraction, because the subtraction sign here. 2 times x minus 2 times 4. I find the arrows really help, guys. So 2 times x minus 2 times 4. So that simplifies to 2x minus 8. 2x minus 8 right there. Oh, common mistake that some people do is they'll say, like for example in this one, 3x plus 6 is 9x. Wrong. These are unlike terms. If I were to model this out, I'm actually going to show you how to model this one out in just a second. And I'll explain like and unlike terms, guys. Hey, this is a pretty advanced one here. You guys think you can do it? I think you can do it. Notice we're distributing over 1, 2, 3 terms. Terms are separated by addition or subtraction. So it's not too hard. We just go the 4 distributes to the x squared, the 4 distributes to the 3x, and the 4 distributes to the 4. So let's do it, guys. 4 times x squared is 4x squared, plus 4 times 3x is 12x, plus 4 times 4 is 16. So notice how we distribute it out, and we get 4x squared plus 12x plus 16. And we can't combine, this is a different term, that's a different term, and that's a different term. So an x plus 2. This is x plus 2. And how many of these x plus 2s do I have?
I have 3, guys. So watch this. X plus 2 and another x plus 2. I have 1, 2, 3 x plus 2s. Notice x plus 2 3 times equals 1, 2, 3 x's and 6 circles. So that's a model of it. Guys, I'm gonna do some for you right now. So get out a paper and pencil, and I'm gonna give you 3 problems to do, and you can do it for your distributive property lesson today. There they are, guys. Pause the video and do it. I'll do a little dance while we wait. Pause the video. All right, did you pause the video? Hope so. Okay, guys, let's do it. Here we go. So you distribute the 4 to the x. So you have 4 times x and 4 times 3. So for this one, you get 4x plus 12. 4x plus 12. This was the distributive property over addition. Now this one's the distributive property over subtraction. So 7 times x minus 7 times 2. And you have 7x minus 14. And now for the hardest one. Let's see if you guys got it. The 5 distributes to all 3 terms inside the parentheses. And we have 5 times x squared is 5x squared plus 5 times 7 is 35x plus 5 times 3 is 15. So we have 5x squared plus 35x plus 15 there. Distributive property, part 2. Hey, this is part 2 to learning all about the distributive property. If you missed part 1, I'll quickly show you. We have the distributive property over addition here. 2 times the quantity, x plus 5. So we would go 2 times x plus 2 times 5. You see how the 2 distributes all the way over. So we have 2x plus 10. 2x plus 10 there. 2 times x is 2x. 2 times 5 is 10. All right, now, sometimes you'll get problems like this without variables. In this case, if they want this shown in the distributive property way, we gotta find a common factor. The greatest common factor would be the best one. So what's the greatest common factor of 14 and 35? What goes into both 14 and 35 evenly for both of them? Did you get 7? 7's correct. So 7 factors in there. And now you have this here. So just like I did here, we're kind of going from this point to this point. 7 times what is 14? If you said 2, you're correct. 2 goes here, good job. Now 7 times what is 35? If you said 5, you got it. Yeah, you got it. Good, so 7 times 5 is 35. So 14 plus 35 is the same as 7 times 2 plus 5. So without all the lines and everything, 7 times 2 plus the quantity 2 plus 5. This equals this. Now, 8x plus 16. What's the greatest common factor of 8x and 16? What goes into both 8 and 16? 8 does. So we're gonna factor out 8. 8 times what equals 8x? 8 times what equals 8x? That's right, x, just x. 8 times x is 8x. Plus 8 times what is 16? 8 times 2, you got it. 8 times 2 is 16. So this would be your answer right here. 12x and 20. 12x plus 20. What's the greatest common factor of 12 and 20? If you said 4, you're correct. So 4 factors out. Now, 4 times what equals 12x? That's right, 3x. 4 times 3x is 12x. Plus, and then 4 times what is 20? 5. So 4 times the quantity 3x plus 5 equals 12x plus 20. They're equivalent expressions. So now 3x plus 18. You guys try this one on your own. Go ahead and pause it. See if you get it. I do a little dance. Okay. What goes into both 3x and 18? Did you say 3? That's right. So 3, and then 3 times what is 3x? So x plus, if this were a minus, you would put minus, a subtraction sign. 3 times what equals 18? That's right, 6. So it's really just the reverse of this one. That's the distributive property part 2, guys. My name is Jason Jacobs. Please like and subscribe, and I'll check you out on our next math video. Keep doing your math, guys. Bye.